Hey, hello and welcome to today's GFG problem of the day. Hope you are doing well. So let's say today's problem, root to leaf path sum. Okay. So what the problem is saying is we'll be given a binary tree, okay, and a target. Okay. And what we want to do is we want to find out whether there exists a path which starts from root to the leaf node, okay, whose sum is equal to the given target. Whose sum is equal to the given target. Okay. So in this case, definitely we have this part 10 to 8 to 5, right? Whose sum is equal to target 23. Okay. So how we'll solve this problem? So we'll do the usual, we'll traverse this tree, right? We'll first process the left subtree followed by right subtree. Okay. So what we'll do? So here we are going to go, when we go to 8, right, to the left subtree, right? So we'll deduct. So whatever node we have processed, we'll deduct that value, node's value from this target. Okay. So 23 minus 10. Okay. 23 minus 10, we get 13, right? We get 13. Okay. So we'll go to further left, right? We'll go further left. And what we're going to do, we have just processed 8. So we'll deduct 13 minus 8 here, which gives us 5. Okay, which gives us 5. Now we'll go to the left subtree, right, of 3. But there exists no child, right? So we will return. But when we go to the left subtree, right? So we are going to deduct 5 minus 3, right? Which will be 2. But when we come back, this will be unwinded, right? This will be unwinded and will be having 5. Okay. And also when we come back, we're going to return false as it's not a leaf node, right? So we have gone beyond the leaf node. So we'll return false. Okay. And also the remaining target value will be 5. Okay. Now we have done processing 3 because it does not have the right child as well. Yes, definitely we'll go to the right child, right? But again, it will return as false. Okay. So we'll go back. Okay. We'll do the stack unwinding. We'll go back to 8, right? So when we go back to 8, what will get back? So we will have this original 13 as a target. This will be unwinded again. This will be unwinded again. And again, we are going to have what? 13, right? We are going to have 13 as a value. Okay. Now we'll do what we have done. We have processed the left subtree of 8, right? Now we are going to go to the right subtree. So when we go to the right subtree again, we had this target, remaining target is 13. We will deduct this 8 from this remaining target. Okay. And it is going to give us 5. Okay. It is going to give us 5. Now when we come here, right? When we come here, okay, when we come here, we will, this is now what we'll check if it is a leaf node. Yes, it is a leaf node, right? It is a leaf node. We will see, we will deduct this node's value when it is a leaf node, right? We will deduct this node's value from the remaining target, okay, which will give us 0. So which means that there exists. So this is the path, right? This is the path definitely which starts from root and which is ends at this leaf, and there exists the sum 23. Okay, so we'll return true from here. Okay, we'll return true from here. Okay, so we'll return true. Okay, we return true here, right? And from, okay, so we'll unwind, right? So here from this path we got true, and from this path we got false, right? So we are going to do the OR operation, and false true, we'll return true again here. Okay, we'll return true here, and finally definitely we'll process this this right subtree. If it returns false or true, right, whatever it is, right? Anyways, we will do OR operation. From the left subtree we have anyways got the true, and from right subtree we got false. So anyways, we'll return true here because we are going to do the OR operation. Okay, so this is the intuition behind solving the problem. I hope you got the intuition. I think we'll better understand with the code. Okay, so before going to the code, I'll request you to subscribe to my channel. Thank you so much. So okay, so first I'll show you the Java code followed by C++. Okay, so what we'll do here is first we'll check a base condition. If root equal to null, or when we reached, right, to the end beyond this target, beyond this leaf, right, beyond the leaf node, right, when we hit, okay, if the target is 0, that means definitely there does not exist the path over here. Okay, we'll return false here. Okay, now we'll check here if it is a leaf node. How will check? If the left and right child are null, right? Left and right child are null. Okay, if left and right child are null, so what we are going to do? We are going to, we're going to check if target minus root dot data, if it is 0. If it is 0, then we'll return true. That is, we have found the path, right? Else we'll return false. Okay, once we are done here, what we are going to do, we now the main, right? Now what we are doing here is we are going to the left subtree, right? We are going to the left subtree. How? Root dot left. We are going And what will go? Target minus root dot data, right? Or okay, or what we're going to do? Root dot right. We're going to go to the right subtree, right? We're going to go to the right. Okay. So this is the code. So we are first traversing the left, right? We are processing the left subtree, right? And when we are going to the left child, so we will deduct the root, we'll deduct the root dot data from the target. Okay, from the target. Okay. And again, first we'll go to the left subtree. Once we have processed the left subtree, we are going to go to the right subtree. Okay, so when we again go to the right subtree, so we are going to root dot right and we will deduct the root dot data from the target. Okay, so whatever the left subtree and right subtree returns, for example, if left subtree returns true and if right subtree returns false, so we are doing the OR operation here. Okay, we are doing the OR operation, which will true or false, it will give us true only. Okay, so that's what the OR operation. Let's compile. This is a code. So the time complexity is worst case, it is O of n because we'll be processing all the nodes, right? Okay, let me submit it. And the space complexity is going to be O of h because we are using the programming stack, right? So yes, the test cases have been processed. I hope you've got the solution. Thanks for watching. Please subscribe to my channel and like the video. Let's quickly see the C++ code as well. Okay, so here is the C++ code. So that's what. So what we are doing here is first let's check. We are going to the left subtree. When we are going to the left subtree, we are deducting the root dot data from the target. And when we are going to the right subtree, again we are going to the right child, and we are deducting the root dot data from the target. Okay. So what are the base conditions? Here are the base conditions. If we have reached right beyond the leaf node, right, or the target is 0, that is we have reached the mid node only, and then only the target was 0, right? Less than 0, less than 0. That means there does not exist path. Okay, so we'll return false here. Here we are checking if it is a leaf node. Okay, here what we are checking, right? If it is 0, then return true, else it will return false. Okay, so this is a code. This is a code. I hope you have got the code, understood the code. Okay, thanks for watching. Please subscribe to our channel. Have a happy, healthy, and a great day. Thank you so much.